This question was asked in GATE 2018 electrical engineering paper, in which you have to find out signal energy of continuous time signal x of t, which is given by this expression. The NPTEL reference for this question is Principle of Signal and System by Professor Aditya Jagannatham. So the useful data for this question is that energy in the continuous time signal x of t will be given by integrating it from minus infinity to infinity mod of x square of t into dt. So this is the energy contained in the signal x of t, and the second useful data for this question is definition of ramp signal, that is r of t, which you can plot from this. This is your r of t and this is your axis of t, and it is the slope of ramp function. Also, r of t can be written as t times u of t, where u of t is unit step function. So from r of t you can plot, this is your r of t minus 1, and this is your minus r of t. So when you plot the summation of more than two ramps, then their slope will be added. At the point where slope is changing. So in the question you have given x of t as e minus 1 u of t minus 1 minus t minus 2 u of t minus 2 minus e minus 3 u of t minus 3 plus e minus 4 u of t minus 4. So from the definition of ramp function, you can write this one as r of t minus 1 minus r of t minus 2 minus r of t minus 3 plus r of t minus 4. So you can plot this r of t minus 1 as, this is starting from 1 and without positive slope, this is your r of t minus 1. Similarly, you can plot minus r of t minus 2, it will start from 2 and going from a negative slope. This is your r of minus r of t minus 2. Similarly, you can plot for r minus 3. This is your 3, which has negative slope, that is minus r of t minus 3. And for r of t plus 4, you will get something like this. This is your r of t plus 4. So when you add these 4, then you will get x of t graph. Then you will get graph of x of t. So at 1 it has a positive slope, till 2 it has a slope of 1. At 2 you can see this is a positive slope of plus 1 and this is a negative slope which is a minus 1. So when you add these two slopes, then slope becomes 0, which is from 2 to 3. So from 2 to 3, this slope becomes 0, but from at 3, you are adding a extra slope to this 0. So this slope will be minus 1 till 4. So this is your minus 1 slope and this is your plus 1 slope. And at 4, you are adding plus 1 to the minus 1 slope. So it is again slope 0. So this is your x of t graph. Now for finding the energy in x of t, you need to integrate from minus infinity to infinity mod of x square of t dt. So now you have x of t as this is your 1 and this is 2, this is 3 and this is 4, and this value is 1. So this is x is t and this is x of t. So this equation can be written as t minus 1. I am writing these expression by a line equation. If you have a line which has a coordinate x1 y1 and x2 y2, then you can write this line equation as y minus y1 equal to y2 minus y1 divided by x2 minus x1. It is a slope times x minus x1. So from this line equation, I am writing these equation for this graph, and this is constant which has a value of 1, and from 3 to 4 it can be written as minus of t minus 4. So now you can integrate it from 1 to 2, that energy in x of t. So from 1 to 2 it is defined as t minus 1. So x square of t, that will give you t minus 1 square plus 2 to 3, it is a constant, that is 1 square dt. Third integral will be from 3 to 4, and this value will be given by minus of t minus 4 whole square dt. This is also dt. So when you integrate this and by putting limit from 1 to 2, you will get 1 by 3, and second integral, when you put this, it becomes 1, and the third one, when you put integrate it and by putting the integral from 3 to 4, you will get 1 by 3. So the total energy in the signal x of t, you will get 5 by 3. So the correct answer for this question is option D.